Hello, welcome to this walkthrough video on how to use Unec Smart City application I just created. So first thing first, you uninstall, you unzip this file here. First thing to do. All right. So now that we have it unzipped, you double click on the folder, and then you see all the dependent files that should be here before the web application runs. So to run this, it's all packaged, and then to trigger the application, just double click on the .bat file here, and then wait for um, a while. So basically, this particular function calls all the dependencies, the flood risk part of the application. So on the background, it runs the analysis and then generates some imagery based on the source data that's actually fed into the system. So basically, if you check data, you have all these different data information here, even the DEM of digital elevation model of the whole thing, which we clicked to to focus on the area of study particularly. So on our second screen, we have this web application displayed. So I'm using two monitor, so that's why you have I had to drag it in. So you just so some of the things that will come up when you click on the bat file, you have like the different APIs for the routing API. You also have the flood API. You also have the traffic API, and then the front end, which generates what you're seeing here particularly. Because the application is hosted on the local system, so yeah, for now that is why I had to create it such a way that it runs on every system, and especially Windows. So you don't need to host it online. As far as you're connected, you have access to this folder whole like this. You can make use of the application. All right. So going forward, so basically it has components, and one of the a few things we try to implement in this particular application is to create a system whereby um, it's a digital twin, which is like a model of what is already existing. And then we implement building LOD, right? For instance, the one you're seeing right here, right? And these are the exposed attributes of the buildings, right? So we can also choose to just to make it clearer, just change the base map. So I implemented in such a way that you can choose a variety of base map based on what you need, right? So the implementation of LOD, for the user to effective, right? And then for the area of concentration, the area of study um, around Unec and environs, we settled it to about 1,747 buildings, basically. And then apart from the LOD CTGML data, then we also have implemented here to make it, smart and a functional digital twin. We implemented flood risk in such a way that if we enable it, we're all going to see it, right? You'll see the information about the flood assessment that was done. Immediately the application was triggered by the .bat file, right? So it runs the whole analysis on the background using hand model, and then um, feeds the web application based on the information processed in the background. So you have flood risk analysis here, and then you have traffic simulation. So we implemented also Sumo, which is uh, an OSM dependent on OSM, node network layer, where you get to simulate traffic, based on Sumo. We also implemented, connected it to a live API for air quality, and also simulated weather forecasts and rainfall simulation. Basically, we are going to see all this. And then finally, we also implemented emergency response system, where can, depending on where you are within the school campus, you can click and then you see in real time a vehicle navigating the roads, and then it will tell you how long it will take to get to the point of rescue. It could be a hospital, it could be fire service, it could be police, as the case may be, right? Time and distance, Yeah, so that is an overview of what the application does. So having confirmed the buildings, let's enable flood rates and then see exactly how it works. Yeah. So we created in different layers based on the analysis I told you that was run on the background. So we have 5 years projection, 10, 25, 50, and 100, as the case may be. Yeah, so basically here now, so as you can see, all this information right here. So we have all these windows you can minimize. And then because we've enabled this, you can see, okay, let's view high risk building. So it will take quite some time and then load. So based on the computation we did, there are no high risk buildings, within Indigo campus. And then when you study the documentation of how I told you earlier that we used hand model. That is the basis for our analysis. So when you study our document, you will see the reason why Indigo campus, particularly buildings here, are not at risk, right? So that is that about that. So you will be able to see the flood risk information, So, but then if you are to do the whole of Enugu city, you start to see some areas that are prone to risk depending on their level. So usually you just click and then you see the risk information comes down, elongated, here, right, just below this other information on that table. So that is that for the building information, right? So let's say we disable this, and then for the air quality, this one gives you an update information the whole of, because it takes larger scope. So you zoom out and then you get to see the whole of the area. It gives a warning the whole of Enugu, and then says the campus is inside Enugu metropolis, right? So it's within the area of coverage, right? So, like, you know, the area of coverage now is this whole circle you're seeing, right? It changes with the color we have here. So, for instance, it says unhealthy at 120, right? And then it gives you parameters for what makes it unhealthy, all this NO2 gas, ozone, O3 uh, gas, you know. So all this information here, you can verify them from the um, Open World Map API, Open World Weather API, right, and all. So it's and all this information are also documented in the methodology aspects, right? So let's even go deeper, and then let's say we have an emergency, and then something happened here, right? And yeah, so let's say we want to use this particular point, and then we have like a fire service situation, you know, right? So an emergency here, fire incidents, and then you want to call the fire service. Just you've selected fire service here, and then if I identify this particular point, just click dispatch, and then it will automatically create a route and send um, fire service, vehicle from Enugu Fire Service, and then you see it in real time, coming, and then you see the distance, covered and time elapsed, you know, total time 9 minutes, all things being equal. So this is based on actually what's we implemented, and then you see it here. So basically, it runs, and then yeah, okay, let's see. It's quite a distance. So yeah, the big guy is here. See it coming into the gate, and then you see the points we have here. Exactly, we say this notification arrived, emergency team, and that is how that works, right? Yeah, you can select depending on what emergency, and then do the same process, and it works, right? So next now we'll do um, the rain simulation, for instance. Yeah, so let's say somewhere here, and then we want to see for light rain, how long it takes, and uh, how long it also takes for the drainage system to just run off. Enugu is called Enugu because it's on a hill, and then it's slopey. When you look at it, when you kind of zoom out, from Enugu. So Enugu has good drainage system by nature, right? So you have runoff. So it's usually tough, hard for you to see a place that is waterlogged, especially except when you now start moving out from Enugu metropolis itself, and then moving towards from Gariki to Ogo. that area generally is has some lowland area. Um, yeah, so you can also tweak this, to say, let's say, heavy storm. Um, and then as you are clicking all this, it's adjusting um, all this bar, right? So time, speed, elapse. So you can this is just simulation. And then the color of the building changes, with respect to um, flooding, you know. But these are like rare cases. You have extreme, like I said, this is like simulated figures, so it's not real. And then the buildings changes, and then over time it tells you um, the drainage has been completed. That is runoff. They are no longer waterlogged. Water just ran off. But this is extreme. You have heavy storm. It rarely happens, and then usually you just have light rain. Um, yeah, and then the buildings stay the way they are. Right. So that is for the video simulation, and this is uh, the API for this is paid for. So that's why it's just we are using the one that loads like this is not accurate. This is based on forecast prediction, not like live data. The data is live, but it's not based on real, how would I say, actual information. Like for instance, if it's raining in Enugu now, a um, a live accurate data will tell you that okay, it is raining at this particular point in Enugu. But a forecasted live data, which is the one we're using right now, predicts, that okay, it is going to rain. So if it says like Enugu, for instance, right now it says Enugu is overcast with clouds, so Enugu feels like it's going to rain based on prediction. Based on its prediction, this is how it's telling that Enugu is going to be right now. It might be true, it might not really be true. Predictions are not always accurate. So that's the difference between our data source for this. For the proper, API and all, you need to pay and all. But this is just for simulation, right? Um, yeah. So we also implemented, so you can hide building. We also implemented some what's it called, shadow effects. So you see, you got depending on the time of the day, right? The color of this direction of the sun, the direction, the reflection of the sun on the buildings will change, right? Um, yeah, it's 8 p.m. And yeah, I mean, you get the point. So this is basically for all the implementations based on what you can see, right? So yeah, thank you, and ciao ciao.